This section is over solving literal equations, and so we have to ask ourselves, what is a literal equation? A literal equation really just has more letters in it. The letters, the extra letters are used to represent quantities, and we have some letters that are dependent variables and then independent variables. And so if we look at this equation, we have m equals 60h. Minutes is equal to 60 times the number of hours. Okay, this is actually a formula. So we know that if we have 2 hours and we multiply by 60, it's going to tell us how many minutes that we get. So in this particular problem, the letter on the outside is called the dependent variable. It depends on what you plug in here for hours. If I plug in 2, then I'm going to get 2 times 60, which is 120 minutes. So everything depended on what I plugged in here. Okay, this guy is called the independent variable. It's on the inside with all the other stuff. Okay, and so the independent variable in this case is hours. The dependent variable is minutes. Now, we can decide to change the subject of this math sentence here. Right now, we want to find out how many minutes we have. Okay, but let's decide to change the subject to hours. We want the hours to be by itself on the outside. And so what we would do is get rid of what's with hours, which is 60. Right now we have 60 times hours. And so we would divide by 60 on both sides to make that cancel and leave hours by itself on the outside. And then we have hours equals minutes divided by 60. So now this is the dependent variable and this is the independent variable. Hours depends on however many minutes we plug in for the independent variable. So let's look at another formula. In this case, you might recognize it. It's P equals 2L plus 2W. This is the formula for perimeter. The perimeter around a rectangle is 2 times the length plus 2 times the width. And we want to solve this thing for L. We want to make L become our dependent variable. Right now P is our dependent variable and these are independents. But we want to make this guy become the dependent variable. We want him to be on one side by himself. Okay, so we're going to start off by getting rid of the plus 2W. So we're going to subtract 2W from each side, and on the left side we have P minus 2W is equal to what we have left over here, 2L. And the next thing we want to do is get rid of the 2. So we have 2 times L, so we're going to divide to get rid of it. And when we do, we're left with L, and we divide on both sides by 2. So we have P minus 2W divided by 2 is equal to L. So let's try another formula you might recognize. This is the formula for Celsius. If we plug in a Fahrenheit temperature, we'll be given the temperature in Celsius. So the formula is C equals 5/9 times F minus 32 degrees. C is our dependent variable, F is our independent variable. F is inside with everything else. All right, we want to swap that. We want to let F be by itself on one side and everything else be on the other. So the first thing we're going to do is get rid of the 5/9. Remember that to get rid of, when we multiply by a fraction, we can get rid of it by multiplying by the reciprocal of that fraction. So we're going to multiply by 9 over 5 on both sides. So now the 9's cancel, the 5's cancel, leaving F minus 32 on this side, 9/5 times C on this side. And so all we need to do now is get rid of our minus 32, so we add 32 to both sides. So on the left we have 9/5 C plus 32 is equal to F. That's the formula for finding Fahrenheit. F is now our dependent variable and C is now our independent variable. So here we have an equation that just has lots of letters and it's not necessarily a formula for anything. So let's just look, our job here is to solve it for x. So I have ax plus 2a equals 3a. So I'm going to get rid of this first. And so I'm going to subtract 2a from both sides, leaving ax by itself is equal to 3a minus 2a is 1a. And so now I want to get x by itself, so I'm going to divide by a on both sides. Because this is being multiplied, the opposite is divide. And makes that cancel, leaving x by itself is equal to a over a, which is 1. Okay. Our next example here, I have w is equal to 4 times p minus q. So w is our dependent variable, and these guys are independent variables. So they're asking me to solve this thing for q. They said they want q to be the dependent variable. So that means I've got to get rid of all these things and get them over to the other side. So I'm going to take care of this 4 first. It's 4 times this stuff. So I'm going to divide by 4 on both sides. So I have w divided by 4 is equal to this is what's left here, so p minus q. And then I'm just going to get rid of p. I'm going to subtract p from both sides. So now I have w over 4, or w divided by 4, minus this p is equal to negative q. And then I just need to get rid of that negative and I'll be good. I have a negative q, so I want to divide by negative 1 on both sides, and that causes that to cancel, leaving q. And when I divide this term by negative 1, I get negative w over 4. And when I divide this term by negative 1, I get positive p. Okay, the next example uses the distance formula, and they give us different pieces of information and expect us to change our distance formula to make the rate become the dependent variable, and then they want us to make the time become the dependent variable. So I just simplified and wrote down our distance formula. And I said, okay, I want r to be by itself, so it's r times t, so I'm going to get the t to cancel. So I divided on both sides by t, and that left d over t is equal to r. And then I started over. I just started over with this formula, and I said this time I want t to be by itself, so I'm going to divide on both sides by r. So make the r's cancel, leaving t is equal to d over r. So here my dependent variable is t, and here my dependent variable is r. In the original equation, d was my dependent variable. I think that's all.